Hello folks, today we are gonna find the derivative of a rational function y equals to 3x squared plus 4x divided by 2x cubed minus 3. Actually, this question can be solved by using product rule. If we rewrite the question with negative exponent like this, you can see easily y is a product of two functions. So we can use product rule for this. But this time I will use quotient rule because I already made videos about product rule and chain rule. If you want to look at them, I put the links in the description, and also you can click the link at the top. Anyways, we won't use product rule for this time, so we don't need this. I am deleting it. And I am rewriting the rational function, and we can use quotient rule to find its derivative. Let's take a look at the quotient rule first. If we have a rational function like here, let's call top function u and bottom function v. Then quotient rule states that derivative of a rational function is equal to derivative of top function times bottom function minus top function times derivative of bottom functions all over bottom function squared. So we have to find the derivative of top and bottom functions. Derivative of numerator would be 6x plus 4, and derivative of denominator would be 6x squared. Let's substitute the functions and their derivatives in the formula. Derivative of top is 6x plus 4, and bottom is 2x cubed minus 3 minus top function is 3x squared plus 4x, and derivative of bottom function is 6x squared all over bottom functions squared, which is 2x cubed minus 3 squared. Now we would simplify by expanding the brackets. 12 x to the fourth power minus 18x plus 8x cubed minus 12 minus 18x to the fourth minus 24x cubed all over 2x cubed minus 3 squared. Now we can add the x to the fourth terms, which end up with negative 6x to the fourth power. And then we can add the x cubed terms, which is minus 16x cubed and minus 18x minus 12 all over 2x cubed minus 3 squared. This is equals to derivative of y, and it gives us the final answer. Let's look another example. As I told in the first question, we can solve this question by using product rule as well, but I will use quotient rule here. Let's rewrite the y as a rational function. To apply the quotient rule, we have to find the derivative of top and bottom functions first. Let's call numerator u and denominator v. Derivative of the numerator using chain rule is 2 times 2x squared minus 3x plus 5 times 4x minus 3. Derivative of the bottom function using chain rule is 3 times 3x plus 1 squared times 3, which can be simplified to 9 times 3x plus 1 squared. Substituting it into the quotient rule, first derivative of u, let's multiply 2 by 4x minus 3, then write 8x minus 6 times 2x squared minus 3x plus 5 times function v, which is 3x plus 1 cubed, minus the function u, 2x squared minus 3x plus 5 squared, times derivative of v, 9 times 3x plus 1 squared, divided by bottom function squared, which is 3x plus 1 cubed squared. Let's simplify a little bit. I want to write denominator first. Cubed square means to the 6th power. You will notice that we have common factors of 2x squared minus 3x plus 5 and 3x plus 1. Let's factor those out in this step. I made a mistake here. This should be cubed, not squared. 2x squared minus 3x plus 5 times 3x plus 1 squared, and after this leave behind 8x minus 6 times 3x plus 1 minus 9 times 2x squared minus 3x plus 5. Also 3x plus 1 squared in both numerator and denominator. We can divide it out of both and we end up with 3x plus 1 to the 4th power in denominator. Let's expand the brackets in the square brackets in this step. Times 24x squared plus 8x minus 18x minus 6 and minus 18x squared plus 27x minus 45. It is very long expression. I'm gonna simplify a little bit in this step. You will notice that there are similar terms such as x terms and x squared terms. Let's collect them all. 6x squared plus 17x minus 51. After all simplifying, leaving us with the final answer. Here we have another question. We are asked to find the derivative of a rational function which includes exponential expression. We have natural exponential functions in the numerator and exponential function in here. Let's find their derivatives. Derivative of top part is equal to e to the power of 2x times 2. Derivative of bottom part is 3 to the power of x times natural log 3. So we are ready to take the derivative of y. Derivative of top function, which is e to the 2x times 2 times bottom function, which is 3 to the x minus top function times derivative of bottom function, which is 3 to the x times natural log 3, divided by the bottom function squared, which is 3 to the x squared. You notice that we have common factors here, like 3 to the x and e to the 2x. Let's factor them out and leave behind 2 minus natural log 3 divided by 3 to the x squared. Also 3 to the x in both numerator and denominator, reducing them and end up with 3 to the x in the denominator. E to the 2x times 2 minus natural log 3 all over 3 to the x would be the final answer.